Today we are going to learn about exponents and their purpose. First, let's look at the different parts of an exponential equation. If you look at the example here, you can use the acronym BEN for an exponential equation. We start with a base. In this problem, the base is 3. There is a small number, which we call an exponent, kind of above the base, which tells us how many times we need to multiply the base. Here, we have the exponential equation in what we call expanded form, where we write out that we are multiplying 3 by itself 1, 2, 3, 4 times. When we multiply all of that together, we get 81, which you can think of as the number, which is also our product. Now let's look at the different ways we can write exponents. If you look at this sample, we are multiplying 2 by itself multiple times. On the left side, you will see that we have the various problems in expanded form, such as 2 times 2 or 2 times 2 times 2. When we write it in exponential form, we write the number 2 at the bottom as the base, and then we write how many times we're multiplying the number 2 in the exponent spot up top. On the right then, in purple, you see that we have the solution, which you can also refer to as the product, which we are multiplying, or you can consider this the value of the exponential expression. You can obviously see that exponential form has a great purpose. Rather than having to write out 2 times 2 times 2 times 2 times 2 times 2 times 2, we can just write 2 to the 7th power. So, looking at another sample, 4 times 4 times 4, you can see that you're going to have the same solution, product, or value when you write it both ways. You can say 4 to the 3rd power is 64, or you can say 4 cubed. This leads us right into how we say different exponents. If you look at this square here, let's say that one side of it is 3 inches. To find the area, you already know we would do 3 times 3. Written in exponential form, we would say 3 squared, just like a two-dimensional object with the same sides is called a square. Then when we have this three-dimensional cube, we say 3 cubed when we do 3 times 3 times 3. After that, though, it gets pretty standard. Down here, I have 3 to the 4th power, spelled out as 3 times 3 times 3 times 3 in expanded form. Then I have 3 to the 5th power, and it goes on like that with 3 to the 6th power, 3 to the 7th power, and so on and so forth. Now you try it. Here is a scenario. Maggie has a big piece of paper that she folds in half. When she opens it, she sees that she has 2 rectangles. Now she folds it in half a second time. When she opens it, she sees 4 rectangles. When she folds it 3 times and then opens it, she sees 8 rectangles. So the number of rectangles is doubling every time she folds the paper. Your task is to write a numerical expression with exponents that describes the numbers of rectangles she would see if she folded the paper 11 times. You can also solve this equation. Good luck!